Hello, guys, welcome back. And today I'm gonna do a really interesting proof, and it's a high school mathematics proof. We know about this, right? We know about the AMGM inequality, right? So today in our class of probability theory for the IDGMMS and the ISIM stat, we are teaching the students some interesting probabilistic inequalities. We're gonna share that, and we'll see that how we can combine the beautiful aspect of probability theory to prove the high school AMGM inequality. So I will write down two results that the number one result should be the angel inequality and number two result will be the result we used. And I'm going to combine them together in a beautiful blended format to show you the proof and the relationship between that. So let's get started, guys. I'm super excited for this. I hope you're excited too. So let's get started. Result number one. Result number one says that it's an angel inequality. So it says that, just give me a minute, let me write it down. Yes. So it says that if a1, a2, dot an are greater than or equal to 0, okay, if ai are non-negative, then summation of ai I from 1 to n, 1 by n is greater than or equal to the nth root, that is the nth root of the product a1 times a2 times or dot n. So yeah, that's the result, right? This is the AMG inequality that we have learned in our high school days. That's it. Now let's write on the result that we have done in our class today in probability theory, the probabilistic inequalities. It's this, that if x is a random variable, if x is a random variable, then, and g is a convex function. I hope you know what's a convex function. A convex function is a function whose g double dash x is greater than 0 on its domain. That is, g dash x is increasing. For example, like this. It's negative, the slope is negative, and it's becoming more and more. It becomes 0 here, and then it goes increasing. So g dash x is increasing, right? If gx is convex and let's say h is concave, the other way around, g double dash x is less than 0, then this holds. Expectation of g of x, the random variable x, is greater than or equal to g of expectation of x, since g is convex. And for the concave one, expectation of g of x, sorry, h of x is less than or equal to h of expectation of x. The result, right? So how do you combine these two ideas together to create the proof of one? We have done the proof of this using basic stuff, basic real analysis result. And then how can we apply over to this? Let's explore that in the next slide. So let me write it down. So we want to prove that summation 1 by n ai I from 1 to n. Remember, ai are all non-negative. Rather, let's call it positive. We are not interested in non-negative because if it's 0, then if this turns out to be 0, so it does not. I don't care about that case. That's trivial. So let's consider our ai all positive. Okay, that's why it becomes interesting and non-trivial. So now the idea is very simple. Let's observe this. If you take a log here, you see it's 1 by a1 plus 1 by n into a2 plus dot dot 1 by n into an is greater than or equal to, if you take here, it's nothing but it's 1 by n, since a1 a2 dot whole to the power n, it turns out 1 by n summation of log of ai, so it turns out to be this. Check it out. Check the step. I missed two steps out here. Check the steps, the homework for you. Check it out. Just use the logarithm idea. Now, can you see a similarity here? Can you see a similarity? Let me write on the result for you guys. So that was g of or h of expectation of x is greater than equal to expectation of h of x. Can you see the result? You can easily understand that g has h has something to do with the expectation as log, right? So let's take h to be log of x. But what about the random variable x? The random variable x is very interesting. If you consider this to be the expression of x, you can know what to do. X is a random variable. Take x to be a random variable, which takes a1 with probability 1 by n. So x is a discrete uniform. Let's call x as discrete uniform d dot u on the set a1, a2, dot an. If x is discrete uniform on the set a1, a2, dot an, expectation of x will be nothing but this inside term, right? 1 by n times summation of ai from 1 to n, right? It's pretty beautiful. So you get this expectation of x over here. And here, expectation of log of x will be nothing but what? 1 by n, ai goes to log of ai, so it will be summation of 1 by 1 to n log of ai. It's pretty beautiful, right? So using this, and log of x is log of x, if you just derive it 2 times, g double dash x is nothing but minus 1 by x square, which is less than 0. Hence, it's a concave function. Hence, this inequality holds. So you can see that idea of beautiful connection between this Jensen's inequality. It's called the Jensen's inequality. This one is called Jensen's inequality, and this one is the AMG inequality. How can combine them both? The core idea of probability and how this beautiful high school mathematical inequality are coming into the picture together. I hope you enjoyed, guys, just as I enjoyed it. Now, my food for thought question to you is: there's another inequality that is called the GMHM inequality, which tells you that this nth root is greater than or equal to n by 1 by a1 plus 1 by a2 plus dot 1 by n. Sorry, AMHM, yes. So it's not that, it's AM is greater than or equal to GM and GM is greater than or equal to AM. Yes, it's this only. So this is greater than or equal to this. AM greater than or equal to GM greater than or equal to HM. So prove this up. It's pretty interesting. Prove this out. Okay. And yep, so for example, for n equal to 2, you get square root of b is greater than or equal to twice ab by a plus b, which is nothing but it's equivalent to the fact that a plus b is greater than or equal to twice root ab, which is nothing but the am and gm inequality. So it's true. So can you prove this up, guys? That gm is greater than or equal to hm, the harmonic mean. Prove this up, guys. I will see you in the next video. Stay tuned and stay blessed. Thank you for stopping and watching the video. Do this food for thought problem. Share it in the comments how you solved it. And yeah, all the best. I will see you in the next video. Stay tuned and stay blessed. If you like this channel, do consider liking, sharing, and subscribing, and hit the notification bell icon. Okay. And I will see you in the class someday. All the best, guys. Have a great night and a great day ahead. Bye bye.